Hello, this is Ms. DB, and in this video we are going to review some problems from the Chapter 2, Section 3 worksheet. This is on using deductive reasoning to verify conjectures. Remember that 2.1 was on using inductive reasoning. So first you should read pages 88 to 91 in your textbook to get a good overview of what is in this section. Watch the video like this one or the videos that are linked to from your textbook or the longer video that is in your assignment. And our objectives today are to apply the law of detachment and the law of syllogism. These are two types of deductive reasoning that we're going to learn about. This is called logical reasoning that we're going to do. It's how to argue and make sense. So we already did inductive reasoning. That was when a rule or statement is true because specific cases are true, like when we look for a pattern. So here's an example of inductive reasoning. It rained every time the clouds get this dark, therefore it'll rain today since the clouds are dark. So you're looking at what's happened in the past and you're looking for a pattern. That's inductive reasoning. Deductive reasoning is the process of using logic to draw conclusions from facts, definitions, and properties. So if you're using a rule or a definition or a math property, then you're using deductive reasoning. So you might hear deductive reasoning on law TV shows where they say, my client was in Kansas on the day of the robbery, therefore he cannot be guilty. It's deductive reasoning. He's not looking for a pattern. He's using a fact or a rule. All right, so let's look at, oops, sorry, that's my links instead. Here we go. Okay, so here we have, for 1 through 4, you have to decide if it's inductive or deductive. So if it's a pattern, if you're looking at what happened in the past, then it's inductive. If you're looking at a rule or something that is said to be true because of a property or a definition, then it's deductive. So number 1, at Bell High School, students must take biology before they take chemistry. Sam is in chemistry, so Marcia concludes that he has taken biology. That's a rule. That it's a rule that they have to have biology before chemistry, so this is deductive reasoning. Number 2, the next number in the sequence will be 10. 2, 4, 6, 8, blank, blank, blank. You're looking at a pattern or what's happened before, that's inductive. Number 3, Fareed watches the sun set for 7 days straight and determines that it will rise 1 minute earlier on the next day. So he's been doing this. He started out on day 1, he looked at what would happen, he wrote it down, then he did it on day 2. He's looking at a pattern. So then you decide if it's inductive or deductive. And number 4, a detective discovers that a suspect was out of town the day of the crime, so determines she is innocent. So if you're using a rule or a fact, then it's deductive. So finish answering 2, 3, and 4. All right, we're going to talk about 2 specific special kinds of deductive reasoning. These are not the only ones, but they're the 2 we're going to work on. First of all, the law of detachment says if the hypothesis is true, then so is the conclusion is a true statement, and P is true, then Q is true. That's the law of detachment. If P, then Q is a true statement and P is true, then Q is true. So if you know that the beginning part of it is true, then you can say the conclusion is true. The law of syllogism is kind of like the transitive property, which we'll talk more about, but it's when you can, if P then Q and if Q then R are true statements, then P implies R is a true statement. Let's look more about what we're talking about here. And there's way more on this in your book, so don't assume that this is all the information you need. You need to look at your book to explain what these arrows mean and stuff. So the law of detachment is something like this. It's a given fact, an if-then statement that's true. If I get over 90%, I will receive an A. That's our statement. Then he says, I got 96%. If the hypothesis is true, then the conclusion is true. That's the law of detachment. I got 96%. Well, that was over 90%, so then therefore the conclusion part will be true and you'll get an A. That's your conjecture. Okay, here's how the law of syllogism works. There's more to it. If I oversleep, I will miss the bus. If I miss the bus, I will walk to school. So see, there's two related statements where miss the bus equals miss the bus. The conclusion of one statement equals the hypothesis of the second statement. The conjecture then is, if I oversleep, I will walk to school. So you get to skip the parts that match up. You get to skip the conclusion of the first statement because it matches the hypothesis of the second statement. So it's like, what's the final step? If I oversleep, I will have to walk to school. So first we're going to work with law of detachment. And all you have to do is, if this is true, which it is because it's given, so this is already true. So you have to see, do they give you a true hypothesis? If they don't, then your conjecture will be false. If they do, then your conjecture will be true. Okay, so we know that this is true. If you want to go on a field trip, you must have a signed permission slip. So what do we need? We need, if you want to go on a field trip. If that's true, then this must be true. Conjecture is, then they say that Zola has a signed permission slip. But this is backwards. So then that's giving you the conclusion, not the hypothesis. So the conjecture is that Zola wants to go on the field trip. This is false. You can't make the conjecture backwards. You can only go in this order. If you want to go on the field trip, then you must have a signed permission slip. Let's look at the second one. If you ride the Titan roller coaster in Arlington, Texas, then you will drop 255 feet. So this is the hypothesis. You ride the Titan roller coaster. This is the conclusion. We need to know that the hypothesis is true. Michael rode the Titan roller coaster. Yes, he rode the Titan roller coaster. He rode the Titan roller coaster. Therefore, the conclusion will be true. You will drop 255 feet. Michael dropped 255 feet. This one's set up exactly right. This one is true. The hypothesis is true, so then the conclusion will be true. And then number 7 says, if the side lengths of a rectangle are 3 and 4 feet, then its area is 12 feet. Okay, that's our hypothesis, is the side lengths of a rectangle are 3 and 4 feet. That's our hypothesis, and the conclusion is its area is 12 feet. So what they need to tell us to use the law of detachment is they need to tell us that this is true, that the side lengths are 3 and 4 feet. Do they tell us that? Yes, they tell us this. It matches exactly what the hypothesis is. So therefore, the conclusion is true. The area is 12 feet. This is perfect. This is true. They did it in the right order, and it matches. We can use the law of detachment. Okay, now the next ones we have to look at the law of syllogism. That means that the hypothesis of the first has to match the conclusion of the first has to match the hypothesis of the second. So here, let's underline the parts. This is our hypothesis of our first. So I'll put that in dashed lines. And here's our conclusion. So what it says is, if the gossip said it, that's our hypothesis, that the conclusion is it must be true. Now here's our hypothesis of our second statement. Does that match? Do these two match each other? Look at, they're almost exactly worded the same. I'll bold them. Must be true. It is true. They're the same thing. So the conclusion of the first statement matches the hypothesis of the second statement. And here's our conclusion of the second statement. The law of syllogism says that you can jump over the parts that are true and just make a new statement using these parts. If the gossip said it, then somebody is in big trouble. Okay, and then they're given that the gossip said it, somebody is in big trouble. It's exactly the way it should be, to do the law of syllogism. If the gossip said it, yep, the gossip said it, matches that part, then somebody is in big trouble, somebody is in big trouble. So this is absolutely true. it's written correctly, it uses the law of syllogism. And notice that we're not discussing what gossip means, who gets in trouble. We're not going to put any judgment into this at all. We're just looking at the words and the statement and seeing if we can use the law of syllogism. Okay, here's our given statement. If you are human, then you are not immortal. Now, we're not going to judge what that means or anything. We're just going to look at the words. This is our hypothesis of our first statement. Here's our conclusion of our first statement. Now, we're supposed to be using the law of syllogism, so we need a second statement. There's no second statement. They just said Fido the dog is not human, but we need another statement to be able to see if the conclusion of the first matches the hypothesis of the second. We cannot use law of syllogism I think this is supposed to be an I too. We cannot use the law of syllogism if there's no two statements. So there's no conclusion of our first cannot match a hypothesis of a second because there's no second statement. So we can't answer this question. We can't determine if the conjecture is true because it's not enough information. So then number 10, let's see if this works. If it is raining, if it is 7:30 p.m. on a weeknight, that's my hypothesis of my first statement. Let's underline that. Then I am studying. I can put a then in there if you want. Then I am studying. That doesn't change it. Okay, so I'll make this be a solid underline. That's my conclusion of my first statement. Now here's another statement, so that's good because you need two statements with law of syllogism. I am studying. That's my hypothesis of my first. But look at, these two things are the same thing. They match each other. If I am studying, or then I am studying, I am studying. They're the exact same thing. Then the radio is distracting. I'm going to underline that with the solid line because that's the conclusion of the second statement. But because these two match, it's almost like we're crossing them out. If I can, there we go. And then I'm jumping over the parts that are the same and just going to the conjecture. So if it is 7:30 p.m. on a weeknight, then the radio is distracting. Is that what this conjecture says? If it is 7:30 p.m. on a weeknight, the radio is distracting. It's exactly the same thing as what this plus this is. So that is correct. And you can say, yes, you can use the law of syllogism. I'll let you finish it. Use the law of syllogism. It's set up correctly for that. Okay, then the next part, you're going to be looking at some situations and seeing what your conjecture might be from that. So we'll be using either the law of detachment or the law of syllogism to draw a conclusion or make a conjecture. So here we have some angles, and it says if two angles are congruent, then they have the same measure. All right, that makes sense. In the figure above, angle BAC, that's this angle, is congruent to angle CAD, that's this angle. Write a conjecture. So if they're congruent, that's what this is. These two parts are the same. This matches this. Now it's worded differently because they're talking about a specific angle in the second one rather than just if two angles are congruent, rather than just a definition. So those match. So the hypothesis of both are true. So therefore, the conclusion will be true. So the conjecture will be they will have the same measure. It's just this right here. That. So the hypothesis of the if-then statement is two angles are congruent. The conjecture is valid using the law of, this was called the law of detachment. All right, let's look at number 12. Number 12, we have this angle here. It's 132 degrees. You are given the following statement about angle S. If 90 degrees is less than the measure of angle S, is less than 180 degrees. In other words, if this angle is between 90 and 180, then S is obtuse. If S is obtuse, then it is not a right angle. So do you see how the conclusion of the first statement is the exact same thing as the hypothesis of the second statement? S is obtuse, S is obtuse. This is the law of syllogism. We have this hypothesis, then conclusion. If this hypothesis is equal to this conclusion. So we can jump over, here, let me even cross them out kind of. So we can jump over that part and say that if this is true, if the angle is between 90 and 80, then it is not a right angle. So we have to figure out what is the hypothesis of the first statement. And the hypothesis of the first statement was that the measure of angle S was between 90 and 180. That's P. Then we have the conclusion of the first statement. That was S is obtuse. And then we have Q is the same in both, S is obtuse. And then we need the conclusion of the second statement. It is not a right angle. So the conjecture, is this valid or invalid? It's valid. Based on the law of syllogism. And then for 13 and 14, I think there's two of them, all you have to do is write a conclusion. You don't even have to say whether you're using law of detachment or law of syllogism, although you can. So here's 13. If you leave your car lights on overnight, then your car battery will drain. If your battery is drained, your car might not start. This is law of syllogism. If this matches this, it's law of syllogism. Alex left his car lights on last night. Your conclusion is just going to be one simple statement that says this. Except instead of your, you'll put his. His car might not start. That's all you have to write. Number 14, if it is raining, the baseball game will be postponed. It is raining. What's your conclusion? The game will be postponed. That's all you have to write. The baseball game will be postponed. That's the conclusion. Okay, this video got a little bit long, but I hope that helped you complete your worksheet. Please let me know if you have any other questions.